Okay. Listen, there's another big aspect of functions that we like to ask you about. There's this topic, and this can be a little. Students need a little getting used to here. There's this domain and range. So the domain, my definition of what the domain is this, and it's a set, and that's kind of a key word. It's a whole set of numbers. It's not just one number. It's a whole set. It's the set of all possible input values, or who's usually our input? X values. So it's the set of all possible input values. And the range, maybe you can guess, is the set of all possible Y values, or output values, or Y values. So it's a whole set. Take a look at this picture. I had this picture here, and I'll just keep it here, but I'll put some labels on it now. Let me label this place over here -6. So that's kind of -3. Sorry, -6. This is on the x-axis. 3, 6. I'm going to call this 7. I'm going to call this -5. And on the y-axis, so with those labelings, and notice something about a function. When I'm going to be clear about this. A lot of times when I draw a function, I put little arrows on the end. If this had little arrows on the end, you should that means something. It means it keeps going, and so this would keep going. Now I didn't have that, so let's get rid of those little arrows. With these little dots on the end, that means this function sort of stops and starts at these places. So this is a little function that just lives here. And anyway, I want to know now the domain and range. I said domain and range can be a little bit tricky, but not from a graph. I think from a graph, domain and range is a lot easier. When you're staring at this graph and you want to know the domain, it's the set of all possible x values. And I would sort of look on the x-axis and just try to figure out where does this function live and what's the lowest x it ever gets to. Tell me.
-6.
Thank you. And what's the highest x it ever gets to? 7, right? So what's the domain for this function? All the x's between -6 and 7. Now, we practiced writing this the other day. How do you write this? You could write this. X is less than or equal to the 7, but at the same time, it's greater than or equal to the -6. But we also practiced interval notation, so you could write, and your My Math Lab homework might get a little picky on how they want it written. They may request you to write it like this. They may request you to use the interval notation, which is really easier once you know it. The interval notation would be -6, 7. Do I use brackets?
Yes.
I use brackets because it actually gets there. See, it's a set of numbers on the number line. So that's what we practiced the other day. Those intervals are sets of numbers on the number line. So good, that's easy. Domain and range visually to me is kind of easy because I can see the left and the right, furthest left, furthest right, possible x's, all possible x's. What about the y's? The lowest and the highest y, the range is what?
-5 and 5.
negative 5 to 5. You know, there, that's it in English, negative 5 to 5, including the negative 5 and the 5. That's it in English. You write that mathematically like this, negative 5 to 5, including both of them. Or you write y is less than or equal to the 5, but greater than or equal to the negative 5. Yes, sir.
And on the chance on the graph that the arrow, it's not pointed, it is continuous, we are to do parentheses.
Well, I mean, let's just change this question, if you don't mind. All right, if I change this question to little arrows, that means it goes forever. I mean, that means, so that I got it in my brain, I'd have to visualize, okay, this thing drops. I mean, it goes forever. And by the way, it won't turn around and come back up. I mean, my graph should show all the turning around places, and this arrow indicates, okay, there's no more turning around, it's headed down. And this arrow indicates, all right, there's no more loop-de-loops here, it's headed up, okay? And anyway, right, now, with those arrows on there, could you tell me the domain now? The domain, the x's that it reaches. Yeah, even though this guy gets steep and goes down, you know what he does? He also keeps spreading out a little, and he goes way out. He is spreading out a little bit, and he goes way out there to negative infinity on the x. He sure does. And this guy goes up, but he's also going to the right. So you're right. That one way to say that is the domain is all real numbers. But you can write the phrase all real numbers, but we learned how to say it like you did. Negative infinity to infinity. And when we use infinity, this is finally answering his question, I think. When we use infinity, we need parentheses, not brackets on infinity. We use parentheses on infinity, just because we don't get there. Yeah. What about the range? What's the lowest y it ever goes to? Negative infinity, and then it does a couple nice loops, but then it heads to positive infinity, I think. I mean, this is even easier, actually, right? But you have to see the arrows and understand what they're doing. In a lot of functions, well, there's always exceptions. In a lot of functions, the domain is all real numbers. You're allowed to plug in all real numbers. When I ask you domain and range questions, I make up functions that stop and start, but that's not how a lot of functions work. A lot of functions actually do go forever, mathematical functions. A word problem might have something that stops and starts, kind of, you know. Yes, ma'am?
I'm kind of confused why the range, the second infinity, doesn't have a negative in front of it.
Let's see. So what we do is, you're right. So the domain is the input values, or the x values, right? And so I'm looking at the x-axis, which is like a number line, running from negative infinity to infinity. Okay, so the range is the y values, which is also a number line, but it's a vertical number line. The y-axis, I'm looking at the y-axis, and it goes from the lower end of the y values is down here, where y is negative, and it goes to negative infinity down here, and it goes up to positive infinity up there. So when we write these intervals, we always put the lower number on the left and the higher number on the right. So it goes from negative infinity, way down here, up to positive infinity up here.
Okay.
Is that okay?
Yeah.
All right.
Thank you.
You're welcome. Watch this. Here you go. Here's something. This is a function, or maybe it's not a function. I don't know. Apples. You go to the store. Apples cost $4.99. Peaches. peaches cost $3. Bananas cost they're cheap, right? $1.50.
Kiwi.
Kiwi. Yeah, thank you. I was trying to think of short fruit, short letter, whatever. Kiwi. $6.99. They're quite exotic. Anyway, is this a function? So that's, now I'm back to my 30 minutes ago. Is it a function or not? Is it a function or not? Does every input have one output?
Yes.
I guess so. Every fruit has one price. I mean, what would not be a function is if the apples had two prices on them. Which shouldn't happen, but sometimes you go to the store and that happens. Yeah, I think every input has one price. I think it's a function. So first of all, yes, it's a function. Whether it's a function or not, actually, we can still ask this question: what's the domain and range? And now, you know, this is a little different. We were very mathematical. Now we're more word problem-y. But the domain is the set of all possible input. And I think the domain would be the set of these fruits. And it's only these fruits. So I think you have to do this. Listen now, this is a little different, but I think you have to make kind of a little set. And that's a little set symbol, it's called a brace, actually. And I'm going to put some stuff in the set. What should I put in there? Apples. I mean, I got to do some writing here. I'm sorry. Peaches, bananas, and kiwi. Sorry for my sloppiness, but I'm trying to be quick here. Are you with me? The domain is a set, and it has those four things in the set. And it doesn't have other fruit in the set. I guess I got to go by how this function was presented to me. And the range is a set, and it has some things in it, and it has some prices, and it's just those prices. You just got to list them. Somebody might be tempted to say, oh, well, can't you just say it's from $1.50 all the way up to $6.99? Don't do that, and can you tell me what's wrong with that?
Because it's not being specific. You could say that apples are $1.50, or that, no?
Well, I don't know. Yeah, right. It's hard. Yeah. Listen, I'd say what's wrong with this is this implies that the range has all prices between $1.50 and $6.99. In other words, when you make this is my interval on a number line, and it would include this. Writing it like this would include $1.51, $1.52, $1.53, $2.99. It would include all numbers from $1.50 to $6.99. Do I want to include all numbers? No, I just want these four specific prices. So it's kind of, I don't know, there's depending on the context and depending on the function we're given, we kind of got some different rules. You know, see, the same thing happens. Sometimes students look at this problem and they want to, hang on, let's get back to my dots. Hang on a second. Back to these dots here. Students would look at this sometimes and they'll start writing, oh, -6, -5, -4, and again, if they make me a list of numbers, that's not the domain. What is wrong with this? They are, go ahead.
It's missing the decimal.
They're leaving out all the numbers between -6 and -5. Right, they're leaving out fractions and decimals between those integers. So this is the wrong way to do it for this problem, but it is the kind of the right way to do it for this problem. So, right, depends on how the function's presented. Okay. Okay, we're doing pretty good now. That's a lot of stuff, but that's all kind of in 1.1. And then you should work on some problems and let it sink in. You know, sometimes I was looking at your homework, I was thinking maybe I should have been giving you more homework. I mean, I don't know if the 13 problems or whatever I gave you, if that's enough for it to sink in. Maybe you should do them a couple times, or maybe I should have made it 30 million problems. You know, I don't know, but you kind of know whether you know it or not, and whether you need to work harder on it or not, I hope. So try the homework and see. Again, you can redo the homework. What's kind of nice about redoing the homework is it's computer generated, so when you do problem 3 the second time, I think it has new numbers, and it's the same kind of problem, but it has some new numbers and little different problems, so you get more practice. Let's kind of ease into 1.2. It's still kind of about functions. I don't even know really what to call it here. I should have, but I want to say that they try to make you look at some graphs. Yeah, that's what they're doing. They're trying to make you look at some graphs of functions. And so they give you an equation and try to say, can you please graph this? And so now, you know, in class, you know, with a pencil and a piece of paper, when I graph this, I draw an X and a Y axis and I try to graph it. I think on the computer, there's this kind of nice little graphing tool on the computer where you kind of grab this. They have a graph here. You kind of grab it and move it. You'll have to check it out and see how it works. But you'll get used to it. But if I haven't taught you any specific things, then how do you graph something? Do you know what to do if I haven't taught you? If you don't know anything, what do? Well, kind of like I did earlier today. I mean, what did I do? When someone gives you an equation, you might want to, plot some points is kind of what I call that, but make a chart, or data is what I called it too. And so you just might want to sit there, and I think the homework kind of makes you do this. Maybe they give you a chart and they say plot some points or plug in some numbers. So yeah, again, maybe a negative number would be good. If I plug in -3, I do the math. I get 5. If I plug in a 0, 0 is always good. I get 11. You guys okay? If I plug in a 2, I get 4 plus 11. I get 15. Maybe I need a lot of points. I happen to know that this is a line. Maybe you already know this is a line, but I'm kind of acting like I don't know it's a line. But if it's a line, then I don't need too many points, because I actually only need 2 points, and I can draw a line. I did 3 points. Let's see what they look like. -3, 5 right here. It's not quite accurate. 0, 11 right up here. And then 2, 15 right here maybe. I mean, that's not too bad, is it? And so, give you an equation, please sketch a graph. And if you don't know any hints or tricks, it's kind of a labor, and you got to plot some points. You know, build a chart and connect the dots. Yes, ma'am?
I have one question about 1.1. When we're typing in the domain and range, do you want both of them? The negative infinity to infinity and then the bottom one too?
It depends on the problem. I mean, it depends. Okay, I sort of did 2 problems here. I'm sorry. You know, I had this problem that ended here, and the domain and range answer was here. And then I changed the problem by putting arrows, and when I put arrows on it, there's the answer.
Okay, so when you put arrows, then the top one.
I think so. Yeah. Let's do another one. So you're in there doing some homework, huh?
No, I was just asking. I was writing the notes.
Yeah. Okay. Well, okay. Right. Here's one. try this. Y equals 2x squared. Can I graph this? Again, you're not really supposed to know anything about this graph, although some of you might know some stuff about algebra. I know exactly what this is, but I'm going to act like I don't, and if I don't know anything about this graph, I start from scratch and I build a little chart and plot some points. Again, some people don't know where to start. They get kind of, what do you mean plug some points? What do I plug in for x? They kind of get stuck here, and I kind of told you most of the time you're allowed to plug in anything for x. That, by the way, that stuff you're plugging in for x is your domain. But a lot of times it's anything you want. Again, I like to try negative and positive numbers. I'll try -2 again. Now I got to know how to do this math. I'm plugging in a -2, and I am squaring it first, before you do exponents, before you multiply by that 2. So it's -2 squared, which is 8. Okay, 4 times 2, which is 8. -2 squared is 4 times the 2 is 8. So cool. That's an input and an output. Let me do -1. I think I'll plot more points here. Remember what I said. As soon as there's an exponent on it, it's not a line. It's not linear. And so this guy is going to curve some way. And if it's curving, I think I need more points. This was a line again. This was a line again here. So -1 squared is a +1 times 2. Plug in a 0, please. Thank you very much. I'm plugging in inputs and I'm finding outputs. It's not mysterious. I can do it fast or slow, however you want to do it. If I plug in a 1, I get 2. If I plug in a 2, I get 8 again. All right, that's probably good enough. I'll do one more though. Plug in a 3.
18.
18, because that's a 9. When you square it, it's a 9 times 2. A calculator could help you, but you can probably do some of this in your head. 3 squared is a 9. Some people say 3 squared is 6. That's right, that's bad. They made a mistake. So 3 squared is 9 times 2 is 18. Good. So now I'll plot these points and try to sketch a graph. -2, 8, I do this quickly. I go -2 and I go up 8. I mean, I don't get all freaked out about counting everything. If I make one unit on the x-axis, sometimes I like to make the same size unit on the y-axis. That's for accuracy. Although if the numbers are huge, I abandon that theory too. -1, 2, -1, 2. That looks about right to me. 0, 0. Then over on the other side, when x is 1, y is 2. When x is 1, y is 2. When x is 2, y is 8. And when x is 3, y is 18. Way up here all of a sudden. Again, you may just connect those and you may make those lines. I tried to tell you it does curve, and it's actually curves right here. It's a beautiful parabola is what it's called. We'll study parabolas. Those are beautiful functions. We'll study them in much more detail in chapter 3. Right now, they're exposing me here. I'm in 1.2, and I learned about functions, and they're exposing me to a few different types of functions. But very quickly, we get back. We quit investigating other functions, and we go study lines and slopes and y-intercepts and lines. In fact, that's next. But since I'm down to about 7 minutes, I think I'll just quit today, if that's all right with you. And I think I'll come in Tuesday and get into lines. I may not even want to answer questions. Okay, you guys should work. You should make notes of where you got questions. Maybe you can come see me in office hours and ask me questions. And I will take questions in class, but I sort of feel like I want to push into the chapter before I pause and ask questions. You know what I mean? So I'm going to push for a few days, and then I'll pause and open up the homework and do some questions. So next class I might do a bunch of good lectures about slopes and lines and push on into 1.3 and maybe 1.4 a little bit. So thank you for listening, and have a good weekend.